that flexibility comes with some cost, but I think that people often make the wrong calculation.
So now we have Brian sitting here
Yeah.
in front of us. If we have to consider the pros and cons of using ROS versus developing something of your own, so what would you say would be sort of your opinion? What are the pros and cons? Why shouldn't everybody use ROS, and why do some companies choose to make their own in-house?
That's a good question. So,
You won't hurt my feelings. I've heard all the negative things anyone could ever say.
interestingly, Universe Robots doesn't use any ROS inside. So we avoided that completely when we made Universe Robots. But I think at that time, ROS was not ready for a real-time control system anyway. Of course, the cons is once you get a really mature product, you don't want to have software you don't control yourself inside it. You want to optimize, and if you think first principle, then you want to have only the lines of code that actually is useful for the application. And that's hard to do with an open source library. Where ROS is really, really good, in my view, is if you have a hard problem you want to solve in a few cases, in a few instances, then you really need to use a library, because it simply makes no sense to write all that software from scratch. So there is a question about scale and how much scale you want on your product that I think is making a difference. But you, of course, I'm sitting with the experts. So
I would push back on that a little bit. I would push back on that a little bit and say that you actually, I think people too often think that they're going to end up with like a more streamlined solution if they build it themselves. And what you're actually doing is underestimating your total cost of development and maintenance and ownership of that software that you built yourself over time. There are always going to be special case situations where if you build a custom system for that application, you could make it be more efficient than, ROS is a general purpose platform. It works in underwater robots, and it works on robots on the space station, and people use it in autonomous cars and humanoids. So that flexibility comes with some cost, but I think that people often make the wrong calculation when they look at that cost and they ignore the cost of building it themselves. And
so you're the Linux of robotics. Is that how you look at it? Or
Linux or Android? I'd say
even the
either
data
metaphor.
centers use Linux inside. They don't go all the way down to the hardware.
Of course.
Yeah. So that's kind of your argument.
Exactly.
Yeah.
It's a general purpose platform, but it saves you the savings that you get from having access to this whole ecosystem of all these tools is going to outweigh whatever cost. In most cases, not all. There's certain applications where you might need to build it yourself, but I think those are getting fewer and fewer. And that you're suffering, like you're sacrificing time to market, for example. If you're a startup and you're actually trying to generate earnings, you can get there a hell of a lot faster if you pick up software off the shelf and use it. And like you said, you're almost certainly going to use Linux anyway, right? You're probably going to use a bunch of other open source software for databases and web servers and all that other stuff. You don't write that yourself. So why would you write the robot infrastructure software yourself?
Yeah, unless you have some special application, there will be some limit to how deep you can go in the hardware with ROS.
But a good example of a project we did recently was with NVIDIA. So they have their Jetson single board computers, and they want their customers to build robots around those computers. And what they found and they know that those customers are going to use ROS on the Jetsons. They kind of assume that. And they found some inefficiencies in the way when you're using ROS on that combination of the CPU and the GPU. When you passed a perception pipeline down the GPU, there was some efficiency loss in the way that we were doing message passing through the system. So NVIDIA came to us and said, we really want this to work together really well for our customers. And so we collaborated with them to make changes to ROS to make it take basically full advantage of their hardware. So in a lot of cases, when you encounter those situations where there's some performance problem that you have, before just throwing it away and deciding to write it yourself, you should see if it's fixable. Like whatever that roadblock is, it could be that it can actually, either you or we or us together could actually change it and fix it. So then the next person that comes along doesn't have that roadblock either.
No.
Do you
Yeah.
have any examples from the microchips world?
Actually, so we've been working on the second version of ROS for the last several years, which we really creatively called ROS 2. And it is now gaining quite a bit of traction. And there's a sub-project of ROS 2 called Micro ROS, which is, it takes the core parts of ROS 2 and runs it on like a Cortex-M class ARM microcontroller, where you don't have a full operating system. So that's a case where we're taking the bits of ROS and starting to push them down into the microcontrollers instead of treating the microcontrollers as peripherals. Now they're kind of being pulled into the overall compute environment in a more seamless way.
Mm.